Right, so now we're going to look at the gradients of the line segment, how to calculate the gradients between 2 points. And in actual fact, as long as the points are within a line, you can find the gradient of a longer line for points that are basically within that line, because if the points lie on that line, then basically it means that the gradient is the same for each line segment for the points that you have. So yeah, as long as it's in the same line, that means the gradient is the same everywhere along that line. So calculate the gradients of the line segments. So we're going to calculate the gradients of line segment CD, and then we'll leave it up for an exercise for you guys to calculate the gradients of all the other lines. And please leave the comments in the comment section if you can leave your answers of the gradients for each line segment that you do as an exercise in the comment section down below. So calculate the gradients of the line segments below. So we're going to look at specifically the gradient of CD. Now we use small letter m, guys, please, small letter m to indicate gradient. And then all we do is we say y2 minus y1 over x2 minus x1. Let's not forget that particular convention, because it's the change of y. And please, guys, the error that learners tend to make is that they say change of x over change of y. No, it's the change of y over the change of x, and there must be consistency. If you say y2, make sure there's x2 at the bottom. If there's y1, remember there's 1 at the bottom as well. So there must be consistency there in your subscript 2211. If you say y1, you can say y1 minus y2, then you must make sure that this is x1 minus x2, right? There must be that consistency. Very, very important. That so the difference between your y coordinates. So first and foremost, remember we need to assign. So if this is our first point, we're saying this is x1, that's y1. If this is our second point, we're going to say this is x2, and that is y2. Go to our formula. What's y2? Y2 is 3 minus what's y1? Y1 is positive 1. Remember, a negative and a positive won't change anything. That's why I don't put brackets. Then x2. X2 is negative 1. What is x1? Remember, there's a negative sign already in our formula, so x1 is negative 5. So I put a bracket so that we can ensure that that holds and sticks. Then what's 3 minus 1? 3 minus 1. Just want to resolve the sign in the denominator. Then I will actually add and subtract the numerator and the denominator. So minus negative times a negative is positive 5. So final answer, what's 3 minus 1? 3 minus 1 is 2. What's negative 1 plus 5? It is 4. Now you should know that you can simplify this further, because our answer needs to always be simplified. That means the gradient of CD is actually equal to a half. Very, very important. Okay. Now alternatively, you could use this notation where you say the y coordinate of what? Of C minus the y coordinate of D. Remember, if you do that, then it means you need to say x coordinate of what? Of C, because CC minus the x coordinate of D. You see, 2211. CC DD. You need to just be consistent in that when you write it down. Because if you say C, C, D, your problems. That's how you get errors in your calculations. So the y coordinate of C. So now I'm just going to go straight to the coordinate of C, and then I'm going to go to the y coordinate of C, which is what? 1. Y coordinate of D. Y coordinate of D, I'm going to go to D as my point, go to the y coordinate of D, which is, so there's a minus sign, which is 3. There's a minus sign in the formula, but D is 3. Then C, x coordinate of C, negative 5. X coordinate of D, minus 1. There's a minus sign already in the formula. The x coordinate of D is negative, so I put it in brackets. 1 minus 3. Let's resolve the sign in the denominator, because there's a negative and a negative sign following each other. A negative times a negative gives you a positive. What's 1 minus 3? That is negative 2. What's minus 5 plus 1? That gives you negative 4. Then what's a negative divided by negative? It gives you a positive. What's 2 divided by 4? You get a half. So the gradient of CD, small letter m, is equal to a half. So you have an option here of either going the letter approach, C, C, D, D, or you could start with y coordinate of D minus y coordinate of C and say y x coordinate of D minus y coordinate, x coordinate of C. All right. So it's really up to you guys, and really and truly at the end of the day, you are able to get the gradient if you make sure that you remember that the minus sign is already there for the formula. If ever the follow-up number is a negative, you make sure you put it in brackets. Very important, because things are going to change where that is concerned. So you can now calculate the gradient for the other lines that are remaining. You can pause the video, do the calculation, leave me a comment of the answers for each respective line segment, the gradient, in the comment section down below.